Today we are going to solve one of the CSIR net problem. This problem uh, came in June 2016. So this particular problem is in part C. It states that what is the Fourier transform of this function f of x, which is given as a delta function plus the summation series of derivative of delta functions. Delta function. Okay, so how to solve this particular problem? So the Fourier transform, first of all, we should know what is the Fourier transform of a Dirac delta function. So here, if you see this Fourier transform of any function which is given by this formula, so minus infinity to plus infinity dx delta of x e raised to power iota kx, and since it is a delta at x minus 0, so basically delta function situated at x equal to 0, so its Fourier transform will be 1. So the Fourier transform of a single Dirac delta function is 1. Now we will use the property of Fourier transforms of derivative of a function, so which states that if we know the Fourier transform of a function, let's say f of x is the function and its Fourier transform is g of k, then the Fourier transform of the nth derivative of this will be given by minus iota k raised to power n and g of k. So this g of k we can get it from by taking the Fourier transform of f of x. So here the situation is same. We know the Fourier transform of delta of x, and we are willing to know the Fourier transform of derivative of delta function. So the derivative of delta function will be minus iota k raised to power n. Now the Fourier transform of all this whole function will be given as 1 for the delta function plus summation series over n. Now I can include this 1 inside the summation and start the series from 0, and then it will be minus iota k raised to power n. And we know that this is the summation series, so you can solve this using binomial expansion, and the answer is given by 1 divided by iota k. So since here this n is running into infinite, so the answer of this series is 1 divided by 1 plus iota k. So this option is, I guess, second. So the second option is correct.